Okay, so here I have the script pulled into VS Code on my Windows machine. That's why there's all these errors here. And the first thing I want to talk about is the directories and how they're going to be set up because since it has to do, since OverlayFS has to do with merging file systems and overlaying them on top of each other, right, hence the name, it's very important that we set up some folders to work with. Okay, so I whipped up a diagram in draw.io to explain how the files are going to be laid out. So firstly, we have this overlay folder, and then inside of there we have work, lower, and upper, and merge. So what these folders are for is with OverlayFS, when we do a merge, we need to specify a work directory, a lower, an upper, and then where it's going to go to, so a merge folder. This allows us to have all of those met, so this is kind of a working directory for OverlayFS, and then what the lower and upper are for is this, since it uses like a union file system, so it unions the two file systems together, if they both have a file with the same path and the same name, then the upper one will be chosen. Additionally, once those are merged, they'll go into the merge folder. And then we see we have also these two magic folders. And what this will, what we'll essentially do is we're going to modify our file capabilities here so that we have access to everything. And then we're going to access that by going through upper magic. Since these two are merged, it's going to lead us back to here. So it's going to give us all those permissions. And this takes advantage of the fact that this version of OverlayFS doesn't actually verify whether or not you're allowed to modify certain file capabilities in regards to a user namespace. And I'll go more into that once we get back to the code. Okay, so now I'm back. So we just checked out what each of these preprocessor directives are for. And now we can go through the functions themselves. So we see there's a make directory, a write file, and a copy file. These are what you'd expect, so copying the bytes over from one file to another, writing to a file, and making a directory. And then we have this exploit function, and then as well as that, we have our main function. So going through what this is doing is, firstly, we don't really care about what's going on here. We can skip that. But what happens is, the main process forks another process, and then what it does is, if it's the child, then it's going to try running this exploit function, and then it's going to exit. And if it's the main process, we're just going to kind of wait until that child is done. Once it's done, then we can go ahead and open a shell through that path that I showed in the diagram to that folder that has upgraded file capabilities, and it's just going to execute a shell from there. So now I can go through what the exploit function actually does. Okay, so now we can jump into the actual exploit function itself to see what's going on in it. So firstly, we can see there's a remove call, and what that's going to do is there's already an overlay folder. It's just going to go ahead and clean it out. It's going to delete everything, and then it's going to go ahead and make those folders. So it's going to make the overlay folder and then the work, lower, upper, and merge folders. And then what we're going to do next is we're going to create a user namespace separated from any other processes. So first it's going to get the user ID and the group ID for the current process, and then it's going to use this unshare command to make a new namespace. From there, it's going to modify this path to add deny to it so that we can modify the UID map and the GID map paths, and we're going to add the UID and the GID to them. So after we do this, the user namespace is fully set up, and we're going to go ahead and we're going to write to this buffer, and we're going to say where the lower directory is, the upper directory, and the work directory is, so that then we can pass it to the next command, which is we're going to call mount, and it's going to be an OverlayFS mount, and it's going to be put into the merge directory. So it goes ahead and does that, and then the next part is, and I'm not entirely sure what's going on here, but as I understand it, this string of bytes corresponds to the permissions all plus EP. So every permission and then the plus EP, as I understand it, means that the capability is going to be permitted and effective. So once this is written into this, we have this buffer ready to go. We're going to copy this path into the binary merge path. So that's going to be, it's going to be the merge directory /magic. And we're going to go ahead and set the file capabilities. We're going to set the security.capability one, and we're going to go ahead and push this buffer into that. And once that's complete, then we went ahead and modified the file system permissions so we can go ahead and return from this child process. So back to the main function, this child process is going to go ahead and exit. And then what's going to happen is we're going to replace the current process with a shell with this specific path. And this one is going to be, so bin upper, so it's going to be upper /magic. So it's essentially using that path to get back to that merge path. And then from there, we have our bash as root, and we can go ahead and use it to open up the AV password file and do whatever we want on the system. Okay, so now that we're back on the guest account in Ubuntu, we can go ahead and actually carry out the exploit. So if ILS, we just have this exploit.c, and like I said, we can either program this ourselves or this is a freely, openly available file, and I'll put a link down in the description of where it is, and I've talked about it previously in the past video. So what we need to do to this is make it executable. So we're going to run GCC, we're going to pass in that file, and then we're going to call it exploit.o. So as we can see, we can run this now. So run like this, and we can see it runs through, and then we have a bash terminal. But we need to see who we are, so we can, who am I? We can run that, and we can see that we're running as root. So if I do ... so I run ls, we can see that there's that AV password file, and beforehand we couldn't modify it, but if we do cat AV password, we can see that we're given the password, and the password is blinking lights. And that concludes the CTF problem I've come up with for CVE 2021-3493. As in the previous video, I will have links to the SSD disclosure website that contains the exploit.c file along with the NIST page with additional information about this exploit. Both those pages have wonderful explanations as well as what systems are affected by the actual exploit. Feel free to leave any suggestions below and have a great day.